So yeah, hi everyone. Myself Dev Wankhede. I am MTech IIT Guwahati first year student. Today I will be presenting my project on the Qwen Medical Chatbot that I have made by fine-tuning the large language model that understands and answer the queries. So this is the project overview. Here the project focuses on building a medical chatbot by fine-tuning the lightweight model which is a Qwen 2.5. It has a zero point 0.5 billion instruct parameter, and we have fine-tuned this model by using the parameter efficient method called LoRA or LoRA adaptation. We will come to know about this in upcoming slide also. I train it on the custom data set that I have made myself by converting the book named Gale Encyclopedia of Medical Science into a CSV file, and then after making the chatbot, I had deployed it on the online platform of Hugging Face for the real-time interaction. So this is the basic project architecture. First, I have feed the dataset in the CSV format to the model. And after formatting into the instruction prompt, I have done the tokenization, then the LoRA, which I have used for the fine tuning. And after that, I have uh, deployed it on Hugging Face using the Gradio UI. So here we can see is that I have used the multiple dependency like transformer, PEFT, TRL, SFT trainer. So this project focuses popular NLP libraries like transformer and TRL and Gradio, which provides the UI, and the bits and bytes that supports the 4-bit model loading for the resource efficiency. So here we can see first about the dataset preparation. So the book that I have used, the Gale Encyclopedia of Medical Science, third edition, is mentioned here. I have converted it into CSV format. The dataset contains user instruction and the chatbot response. We format it using the instruction style and tokenize it before feeding it to model, means before the training. And one of the example we can see here that what are the herbal remedies for anxiety, and instructions is camel and ashwagandha. So now the model and the training setup. So we use the quantized version of Qwen for efficient training, and we use the LoRA, which helps the training with few parameters, and we log training matrix with the TensorBoard. So basically, what is this LoRA? So LoRA is basically a parameter efficient fine tuning method. LoRA stands for the low rank adaptation. It reduces the memory usage by training the small metric layer instead of the entire model. This makes it ideal for the platform like Colab or laptops. And out of all the model parameters, only 0.5 to 2% of model parameters are updated. Then the tokenization. So this tokenization basically converts the text into tokens or numbers or IDs, because the model doesn't understand the simple English passages. It has to be given in a flat 1D vector. So here we can also see that take medicine is converted into 3 tokens with different IDs. So this tokenization break down the sentence into numbers that the model can understand, and this thing is very necessary for pre-processing step before the training. Then the training matrices, the model trained for 3 epochs with the step size of 624. 3 epochs generally seems very low, but as we consider 0.5 billion parameter, it is higher. With the batch size of 2, and the learning rate is also mentioned. The loss dropped consistently, showing the stable learning, and this TensorBoard helps to visualize the debug training in real time. So here we can see the plots. This plot of train versus loss versus steps, training loss versus steps, confirm that loss is significantly reduced. Before training the model, the loss was 0.38%, and after training the model was loss went up to 0.16%. And another plot of learning rate schedule helps to debug the training stability. inference and result. After fine-tuning the model, the chatbot was able to give a clean and structured response. And here we can see one of the example of health query. When we have asked what helps in insomnia, it have given some numerous variety of foods and supplements to treat the insomnia. So in this way, we can see that now our chatbot can give response to the new queries which are not in the input parameters when we have given the model training data to feed. One of the output we can see here that when we ask the benefit of multivitamin in human body, it gives us this type of answer. And when we asked can holy basil means tulsi help to regulate the cortisol level. Then the chatbot is developed using the Gradio on Hugging Face spaces or repositories. Anyone can access it online and ask the medical questions. The link to my Hugging Face repository or spaces is mentioned here. I will also try to mention it in the description box. After you click on this link, you will see this kind of interface where you can simply type the question and click on submit, and it will take some time, but it will give you the response. So here is the summary uh, where LoRa is used for the efficient fine-tuning. Chatbot understand the domain-specific healthcare queries, and it is a real and light time deployment, and it has a great use case for applied NLP. So this project shows how to train the helpful chatbot with the minimum resources, and it's suitable for healthcare education and automation. Now I will give you the simple and small demonstration and show you the overview of my code. Thank you. So this is my Colab notebook where I have written all my codes. Here, as I had shown earlier, I have installed all the necessary libraries like transformer, datasets, PEFT, TRL, accelerate and bits and bytes. Now these libraries let you train big model efficiently even on the limited hardware like say Google Colab. Then I have installed all the required libraries. Then I have created the dataset. This format helps to learn the model how to map an instruction to an appropriate response during training. So this is the format that we can see, and then I have converted into model understanding dataset. After that the insta after that I have load the base model and the tokenization. This prepare the base model to be fine-tuned using the LoRA on our medical dataset. Again, here I have applied the LoRA configuration. So instead of training the full model like millions of parameters, LoRa trains only small plugin modules. It saves times, memory and cost. Here we can see the trainable parameters. Training configuration, which customize how your model trains the logs process. Tokenization, it prepares the dataset for supervised learning. Then simply fine-tuning the model. This is where actually the learning happens and the model adapts to your medical Q&A dataset. I have trained it to like 624 steps for 3 epoch. And here we can see the training result. Plots of training loss versus steps that confirms that loss is decreasing. Again, we have the plot of learning rate schedule, which helps to debug the training stability. And these plots helps to visualize diagnostic help to prove your model actually learned. Then here are some TensorBoards diagram. It shows the metrics like loss, learning rate, sample second over time. It is the way to monitor the model training interactively. And there we have saved the model after doing this, and we have plot some more curve. And after saving the model, this is the step of inference, means testing that if our model is working properly. So here we can see that in inference, that is testing, we have given couple of instructions like how does insomnia is treated, and based on the new prompt our model is giving this particular response. And in the same manner for another set of input, it's giving this sort of output, and again for this one it's giving this. So instead of doing this one thing multiple times, I have created a user interface chatbot using Gradio. So here we can see it has given us a template of input bar and the response. So here we can actually write any question that we want. Say for an example, what are some early symptoms of tuberculosis? And if we submit it, it will take some time, but eventually it will give, yeah. The early symptom of tuberculosis include fatigue, weakness, coughing, fever, loss of appetite, nausea and diarrhea. These are some early symptoms. So in this way we can see that our model can give the answer for new queries after the training. And these steps are just to deploy my project on the Hugging Face. So yes, this is my Hugging Face profile, you can see here, and this is the space that I have created. It's just like the repository we create in GitHub. So once we click here, we can see the same interface that we have seen in the Google Colab Notebook. And if we go here in file, we can actually see that this response is giving by a model which has fine-tuned by us. So we are not getting the output by the same earlier model, we are getting the output by the model which we have trained or fine-tuned. So yeah, that will be all from my side. Thank you.